Alright, now that we've got the top end disassembled, we can now inspect a few key components to really gauge how worn out this engine is, if at all. It has 6,300 miles on the original odometer. I assume that to be correct. And that's a good thing. That means it doesn't have 10, 15, 20,000 miles on it. So we've got the engine apart fairly young in its life. And from what I can tell, it has never been disassembled for any reason by anyone. So a couple of things I want to go over. Alright, so this is a 1963 engine. It's a 63 Vespa 90 engine, just FYI. That's V9A1T, I believe. Now, there's some uniqueness with this engine that doesn't carry over past the 1966 model year, or 1965 in some cases. This engine features a smaller crankcase opening for the cylinder. It features a smaller wrist pin with a, instead of having a needle bearing crankshaft or rod end bearing, it has I believe it's a copper or bronze or brass sleeve. One of those three metals, or all three mixed together. Anyway, so what that means is, it's harder to find certain parts for this engine. You can't fit a 1966 piston, jug, possibly even crankshaft, onto this engine without machine work. So the supply of 14 millimeter pistons isn't as plentiful, but they are available. The piston rings themselves will not fit. You can't buy aftermarket piston rings that'll fit this piston. You have to replace the entire piston with a modern 14 millimeter piston with new rings. So I couldn't just do a ring job on this engine if I had to. I can't just swap out the jug if I want to. So it's important to me that everything is in relatively good condition to start out with. That way I only have to do minimal work to the top end and then move my way through the motor. This is also a good way to determine what to expect inside the motor. It gives us a quick window as to the engine's overall health. I'm going to actually start by talking about the piston rings and how well they're sealing in relation to the bore. So in this piston, you can see there is really not much wear at all. There are a few very light scratches, but those are normal. I mean, these engines run dirty, they run hard, and they run long. So you're going to find some wear marks at some point on the piston. You can see that the skirt still has a nice matte finish. It's not all shiny looking. The sides of the piston are a little bit darker, and that's only because the sides of the piston don't really see the brunt of the force. All the force is applied to the sides, or to the front and back of the piston. So the skirts are in good shape. The body of the piston is in good shape. The top of the piston is in really good shape. It's not cracked or anything, and there's only a little bit of carbon on there. Yeah, a little bit. Not too bad. Nothing hardened, and there's no collision damage or anything that I can see. Why don't we clean that off a little more and take a closer look. Alright, it looks like this piston top is in perfect condition. There are no signs of any burning or overheating. It's actually perfect. I couldn't ask for a better one. The rings themselves look to be perfect. There is no blow-by at all on this piston. So that's one of the other things we want to look for is, how well is it sealing? The piston shows no signs of any blow-by. There is no blackness or heavy deposits past the piston rings. So they're doing their jobs quite effectively. It's quite a miracle, in fact, that this engine is in such good condition, because it hasn't run in over 15 years. There's no damage to the skirts. There are no deposits inside the piston. It's perfectly clean inside. I don't see any, let's take a closer look here. I don't really see anything in there to be concerned about. The walls aren't scored. They're not scratched. So this engine had a pretty easy life. It wasn't beaten up badly. It was run with a proper mixture of oil and fuel, and whoever owned it obviously took care of it. Now moving our way over to the jug, we'll take a look here. Light. You can see some light scratching, very light scratching. Looks like it's more towards, let's see, it's more towards the, is that the intake or the exhaust? That's the exhaust port, okay. Yeah, a little bit towards the exhaust port. Of course, that's the hottest side of the engine. But I don't think it's bad enough to need a rebore. And that's a good thing, because these jugs are no longer in production. The only way to replace this jug, well, you have a few options. You could buy a used jug. You can bore the old one out to up to about 4 times, I believe. I believe they take 4 bores maximum. Or alternatively, you can have the block machined to accept a 1966 jug, which I have no plans of ever doing. So it comes to, now if this were any other engine, I'd say throw it all away, put a new piston, new rings, new jug, new whatever. You know, if this were my Honda Helix, for example, I would be saying that right now. However, we can't do that. And I want this engine to last a long time. I want this engine to be around when I'm old and gross and falling apart. I want this to be shiny, running like new. And that means boring it out as little as possible. I don't want to basically use up all of my life points right now. To relate it to a video game analogy, I don't want to use up all my health points right now on killing this one guy when I can run away from him. You know, okay. That's kind of where I'm at with this. I don't want to do that. Because I can only bore this thing 4 times. So if the piston and the jug and the rings are in good condition, I'm just going to clean everything up. I'm going to hone the cylinder, and I'll tell you why in a second. But I'm going to hone the cylinder. That's it. I'm not going any further with it. I want to hone the cylinder because honing, the hatch marks actually in the bore, are what help retain the oil film, which helps the piston slide better and helps reduce the likelihood of seizure. Because this engine has no hash marks left to speak of, I mean they're really not even visible, except for the cylinder wall sides, like the wrist pin sides. It's important to have those hash marks there. You know, it's actually quite critical. So I'm gonna do a light honing with plenty of oil. I'm going to finish disassembling the motor. I'm going to replace all the bearings, or whatever I can replace, I'm going to replace, whether it needs it or not. I'm going to do bearings. I'm going to be doing the clutch stack. I'm going to be doing the cruciform in the manual transmission side. All the seals. This is going to be a nice engine when it's done. I'm just not going to go crazy and replace and bore, and not at that stage yet. I am going to check the diameter of the piston and the cylinder with a micrometer. At least I can't really. Micrometer probably won't do me any good here, but it will over here. We'll see how the piston fared. Is it out of round or not? Okay, so there's that. Now here's one quick point I want to point out, because I like to point at things. There is a little bit. Now there is no gasket between the cylinder head and the jug. And the reason for that is these surfaces are precision machined at the factory to not need a gasket. Special attention has been paid to these 2 surfaces to ensure that they will mate perfectly. No sealant, no gasket needed. However, when I took it apart, this is what I found. There's a little bit of blow-by here. A little bit of leakage. Little signs of, like if this were a Subaru, it would need a head gasket because it's leaking. There's some deposits between the 2 surfaces, which indicates that obviously there's not a perfect match here. Now that could be because of a couple of factors. These 2 are made from dissimilar metals. You have a cast iron bore and you have an aluminum head. and they don't expand at the same rate. Over time, that perfect marriage will break down and things will start getting through there. Also, this head could have, as it heated up, it would have maybe warped a little bit, but not a lot, not too much, just enough to allow some carbon to build up in there. And as that builds up in there, it warps a little more and a little more until it finally leaks. Because that carbon, once the engine cools down, won't allow that surface to mate again. The head could be completely warped. Who knows? But what I am going to do, and there's a procedure you can do on these engines that's really easy to do. It's not destructive. You take a piece of plate glass and some sandpaper. I found this on Modern Vespa on one of the posts. And it's this is how you remate these surfaces before reassembly. You basically just take, clean as much of this crap off as you can and just lightly sand it. I would say maybe 1,000 grit sandpaper. It's soft aluminum, so it won't take much. And you sand it on a true flat surface. Ideally, you'd actually want to have this done in a machine shop, and maybe I will do that. And you do that, and boom, you've got your flat surface back. It's going to mate just fine. I am going to explore options as far as installing a head gasket. Now, a head gasket, and why they use them on everything else, is because a head gasket can take the distortion of these two dissimilar metals and, for the most part, not allow anything to leak past it. Head gaskets are designed to squish. Now, as this engine heats up, this expands, and the tolerances between the precision mating surfaces changes just a little bit. This expands outward, and this expands a little bit outward, but not as much, and it also gets thicker. So when it's cold, it may run fine, or it may run really poorly, it may leak, it may do all kinds of things, but once it heats up, it'll seal up. At least that's the theory. Or the other way around. Once it heats up, it leaks, but when it's cold, it doesn't, because of the bolt stretching. A lot of engineering stuff here that I don't quite understand. But what it means is, on a head gasket design, the head gasket will allow for the changes and distortions in the metals without allowing any leakage. And then once everything cools down, it returns to its proper, shape. So that's what I'm really getting at. Without having a head gasket, that can't happen. So I think it's an oversight on Piaggio's part, but I don't know. I'm not an engineer. I don't know why they did this. As far as adding a head gasket, the risk to that would be a couple of things. Well, the thermal transfer properties of these two parts was designed without a gasket in mind. So, as far as heat transfer and proper cooling of both surfaces, it didn't factor in the insulating properties of a gasket. So the engineers did not consider that when they built this motor. The other thing is, you've also increased the combustion chamber size ever so slightly, which will lower the compression ratio. On a two-stroke engine, that could mean a lot of things. You generally want higher compression. It may actually save a little bit of wear and tear on some components on this engine if it were running at a lower compression ratio, but I don't really plan on changing that at all. So I got to do some research on what I should do about this and what I should not do about it. For now, my plan is to do the sanding method, which will just lightly raise the surface and hopefully make it flatter. So let's take a quick look inside the crankcase before we split the case. By the way, we are not splitting the case in this video. That's going to happen later on. Okay, so we've got our, this is a reed valve engine or not? I don't think it is. Let's see here. No, this is not a reed valve engine. Unless there is a reed valve in there. Two strokes typically have reed valves. which are what allow air to be sucked into the crankcase through the intake. But once the compression stroke or the power stroke hits, it doesn't allow anything back the other direction. And I believe these have a reed box inside the intake here. But let's take a look at the we don't want to risk damaging anything. We don't want to get anything scratched up here. I want to see what the top of the counterweights look like. It looks like this engine uses the crankshaft counterweight as a valve, which is quite interesting. Later model Vespa engines, or at least one or two models, I don't know which ones they are, but they use like a scrub. I believe they're called scrub wheel or buffer scrub pad engines or something, and they use a tightly machined crankshaft as an intake valve, and rotor buffer, rotor scrub rotor. That's it, or rub rotor. I gotta look that up. Anyway, you're gonna hear some snapping noises. There's some stuff lodged behind the flywheel. It looks like it does use the crankshaft as a makeshift valve. That's interesting. I kind of wonder how well that works. Well, it obviously works well enough to... Yeah, you hear that? There's something behind here. Something behind there. Alright, I just took the this little magneto cover off. And it looks like there's a little bit of corrosion and there's some rusty flakes of whatever kind of stuck behind there. I'm going to say that the crankshaft seal might have been leaking like a freaking sieve, because if you look at the if you look around here, there's a lot of oil, a lot of buildup. It looks like engine oil and fuel or whatever the hell, and it's thick and nasty. Oh man. Now, generally, when a two-stroke leaks at the flywheel, it means that it runs lean, and it runs lean because it's sucking in air from the crankshaft seal. I don't think I've ever seen one with that much filth behind the flywheel. Something had been leaking in this engine for quite a while before it was finally put to rest. And, my lord, it doesn't look fun. Oh boy. So I gotta get a circlip, set of circlip pliers. Because I gotta pull the piston off, I gotta take this flywheel off, and there's a circlip that holds something there. But it's a one-piece flywheel. I thought these had a two-piece. It was like a flywheel, magneto, and a fan. But this is one piece, like a lawnmower engine, basically. And this gives you access, by the way, to the to adjust the ignition points. And yeah, so there's your ignition coil. Here's the points right there. I think a better light. There we go. There's the points. And those are all getting replaced. They look good though. They don't look burned. But they do need a good cleaning, and I'm probably just going to put new ones on when I have it apart. Basically, I'm going to do everything but the top end. That's pretty much where I'm at. But look at all that oil. That's oil buildup right there. It got sucked in from somewhere. And you can see it been spraying all over here too. You know, I wonder if the base gasket had been leaking. Oh, that would make sense. If this gasket was leaking, that would make all kinds of sense. But yeah, we got our work cut out for us. But the key takeaway here is that the engine is good. It is a good candidate for a refresh. You know, it's We're talking seals, honing, a little bit of head work, clutch job, ignition, and we'll see what the bearings look like. I mean, I don't want to run out and buy all new bearings if I don't have to, but we'll see how they look. And I'm not gonna draw any conclusions until I see the inside of that engine. So until that time, have a good one. At this point in time, as far as update frequency, you're not going to see a lot on this project. I'm going to be working on this over the course of a year, possibly longer, depending on funding and parts availability. So, it's going to take a little bit of time for me to get any real work done on this bike. But for now, it's not really in my way. Well, it is now, but I'll be moving things around. So it'll come. It'll come when it comes. I just had a conversation with a gentleman about bodywork, and that's going to cost me. It's going to cost a lot of freaking money. Probably a little under $2,000 actually to have the body done the way I want it. I did price out. I went through every parts list for this scooter, and I looked at what I need and what I don't need, and I priced out everything that I need to put it together as it sits today, and I got a total of about $1,300, including shipping from Germany. So I'm going to have to piece that apart. I might have to split the order up and try to find some stateside suppliers and see what I can do with that. But around $1,300 for everything. And I might send them a letter or send them an email and see if they can't come down on that a little bit. Maybe give me some dealer pricing because I'm buying so much at once. But yeah, to do a full rehab on this scooter, that's including tires, about $1,300. That may sound like a lot of money, and it is a lot of freaking money. But that's about what it cost me. It actually cost me more than that to do all the work I did to my Helix. So, I mean, it isn't that bad. And it is an antique that will appreciate in value, whereas the Helix is depreciating in value because it's being driven like a bat out of hell. But because this is an antique, a priceless artifact of Italian heritage or whatever you want to call it, it's worth putting some money into. And I want to get as much as I can done while I still can.